No, not totally. Oh, it was muted. Okay. So you can find my contacts here. The last website here is just aggregator of my social networks, because Slavic surnames are complicated, I guess. You are Polish people, you actually know about it, so. Today I'm gonna talk about backends, about Node.js, and about Koa framework. 2 years ago I given a talk about how cool it is. Afterwards I worked a little bit more with it and found some pitfalls which I had to overcome, and now I'm talking about it from the different perspective, a little bit more depressive, but we'll figure out what's about. I'm giving this talk third time already. I was talking about it in Hanover and Berlin, and it slightly differs from what was there, so if you've seen those videos, it's not the same talk. So, I'm trying to keep agenda pretty simple. In the first place, I will talk what is Koa, and afterwards, we'll try to build something with this. And I will share my experience, good and negative sides of it. First time I came to my team and said, guys, I found a very cool framework. It's called Koa. Could we use it? Because, guys, it's cool. It's required by team of Express. They say it's like, it's better than Express. You should use Koa. But nobody was happy, obviously. And I had to do some research and explain why we should use it. Since that, things went not the way I expected them to be. And I expected to see some raise, but you can see that actually nothing has changed during the last 4 years in Koa ecosystem. On the one hand, it correlates with Express and all JavaScript Node.js ecosystem, so it looks like it's stabilized. There is no such a big hype around it anymore. However, considering and comparing three technologies, three Node.js frameworks, we can see that, well, nothing is changing, and Koa.js definitely not taking some leadership. It stays on its place when it was. So, we can take a look at contributions, and you might think that it's dead, however it isn't. The point is that Koa is fairly simple. It's just a core, and actually there is not too much code to contribute in. So it just works. And if you see what Koa is inside, you can notice that it's not Express, and it's just a middleware core. It doesn't have any routing, template engine, HTTP utilities. It doesn't have anything inside. So it's just a simple middleware core with built-in web server. And it was one of the reasons why I decided to choose it. Like, I thought I would have total control on things what I am doing. Why Koa? Another reason is event loop. Please, guys, raise your hands who worked with, who understand what event loop is. It's cool. And by the way, guys, who used Koa on your projects? Okay. It's fine. So I'll just highlight, in order to remind the context, that actually event loop is something which allows us to do some asynchronous stuff in JavaScript, and the point is that we'll execute the scale code and we'll have 1, 3, and 2 afterwards, even we have 0 in timeout. And there are many ways how you can handle asynchronous operations. One of them is using callbacks. You can use promises, you can use many different stuff. And also in Node.js, I was inspired by some synchronous functions. Sometimes they're useful. If you find with the fact you're going to be blocked, it's kind of okay. And I was looking at it and I thought, probably I can have all the stuff on my backend like this, because usually I have some controller and I have some logic inside. And well, it's not too much asynchronous. I mean, usually on the backends, I don't have a lot of stuff which should be executed in parallel. Usually when I'm waiting for some callback, nothing is happening in parallel for this particular user and for this particular request. So doing something like this was one of ideas I had in my mind, and there are actually several ways what we can do. We can use promises, and since ECMAScript 7 promises are monadic, so you can call them as many times as you want, and it works like a map in monads. Also, there are some approaches like generators and async await and observables. Observables are not part of specification yet, however, they are leveraged by RxJS pretty well, and will actually solve our spaghetti code problem with two of those. We'll take a look at generators and async await. Actually, generators were the part of Koa.js 1. They allowed to do something what I presented on the slide with synchronous Node.js function, and also current version of Koa.js, it works on async await, and we'll focus on it. So, what async await is, I prepared fairly small code example, and Alexander, if you don't mind, I will turn off the lights because I'll try to show some code, and I'm not sure it will be visible for guys. Oh, cool. Romantic atmosphere, yes. So the code is pretty simple. Could everyone see it? Okay, so here is an example of probably the simplest Koa.js application you can create. And there is some simple story behind it. Last night, I created a fairly useless library. It was kind of parts of the joke. One guy's created useless library. I decided to create another instead. I thought it's gonna be a good joke, and I'll promote my GitHub. So I created something like this. It's absolutely useless joke. It's just does something like this, and it takes time. So it's absolutely useless. As you can notice, it adds method to make any color, so 8,000 functions. So fairly useless joke. I expected to do some hype with it, and I tried to solve two problems I had. I really trying hard to promote my GitHub and Twitter without no luck, and as a human, I always validate like, oh, 10 minutes came, probably I got new subscribers, you know, something like that, because it's pretty natural, and it doesn't make a lot of sense to refresh all those pages all the time, so I decided to create something like this. Just, I would make it bigger. So, something which will parse my Twitter and GitHub and take all the information I'm looking for, just to fulfill my expectations or break my heart, and I will show this application. It was just a good example how to show the situation when we have a lot of asynchronous stuff inside. So here we have some imports. Fetch is just Node version of Fetch API from browsers. Cheerio is some kind of jQuery for big backends. It allows me to do some parsing on HTML. And actually, here are two links, like my reference to my GitHub repository and to my Twitter account. And some classes, because actually I tried to use Twitter API, and they said I need to obtain some API key. I said, okay, fuck you, and decided to go without it. So I just parsed HTML, it's much faster. So what we have inside, we have, we take GitHub data. It's API just regular endpoint with JSON. It's asynchronous operation, and we can use await. So this body helps us. So we can declare a async function, and we can await for any promise. So basically, fetch here it's pretty similar to fetch in the web. So if we'll use it without async await, it's gonna be something like, fetch something, doesn't matter what, then we'll get some response, we'll make JSON out of it, and afterwards we'll assign it to some variable here in the next den. So something like this. I'll keep it for a while. And this code allows me to do the same, but writing some kind of pseudo-blocking code here. So here I take data from the GitHub, here I take data from Twitter. So I do 4 asynchronous operations inside one function, and I don't use any callbacks, so kind of blocking operations. And afterwards I just get stars from the JSON, and with this code I just extract the number of subscribers from HTML I got from the Twitter. And setting body a return result, which I have. So coming back to the code, at results we'll get something like this. I can refresh it, and you can notice, oh, we got some progress. I'm pretty happy, guys. Thanks. So coming back to the presentation. Oh, yes, it is here. So async await is something about what I just presented. I need to take it away. And I mentioned that Koa is, okay, I guess I can turn on lights. Oh, sorry for that. I mentioned that Koa is an engine of middlewares, so some core which allows me to use middlewares. Please raise your hands who used Express at least once. And keep your hands up who created at least one middleware for Express. Okay, middlewares for Koa are pretty similar to ones in Express, and there is some syntax difference, there is some context difference, but the idea behind it that it's just a pure function which takes arguments, returns the results, and does something with context. And we have some context and callbacks. And the point is that context isn't passed to each of those functions. It's mutable. It is located outside. And as far as soon we don't have any asynchronous executions of middlewares between each other, it's not a problem. We shouldn't care about any state management because they are executed one after each other. There is no possible other cases. And context is shared. That's why it's fast. And we shouldn't recreate the whole object all the time. And we have encapsulated request response. It's just a small difference between Express and Koa because Koa leverages all this stuff in one object. And as I mentioned, they are executed synchronously. So middleware is something like this. So this is a middleware, just a function which takes context, which takes next, which is callback, and after doing something asynchronously in any way you want, you'll call callback next. Before going further, you might ask me, because people usually ask so, what's the difference between writing something like this and writing the same in Express? The difference is performance. Koa.js is slightly faster, and difference is error handling. You shouldn't write try catch between all this sequence of await functions because all those catchers are implemented inside the core. In case of Express, you get an error and it won't be handled. It won't be catched. So you need to care on your own if you're doing it in Express. So coming to APIs question. When we were working on Koa.js, I expected it to be faster by architecture. I was wrong because we are usually wrong. And I had to face three biggest problems. First one is concurrency. Second one, some databases optimizations, and the last one, HTTP. After complicated backend technologies and big like enterprise frameworks, situation in Node.js appeared pretty pretty weak, and there weren't a lot of enterprise scaling technologies, so we had to care about everything on our own. And another problem, it's particularly related to Koa, is that quality of libraries is kind of terrible. I tried to use Koa GraphQL library, and I found a bug inside. I fixed it. I opened a pull request on November, and it was fixed like in February or something like that. I mean, approved on February or something like that. So nobody really cares. Popularity isn't that big as it might be, and comparing to Express, quality of libraries isn't that good. I got to some question afterwards, like, okay, if quality of Express middlewares is better, why couldn't I use Express middlewares instead? And actually it's possible. We have incompatible APIs. However, you can wrap your middleware inside some adapter and it will work. I mean, technically, it's absolutely possible. There are even some libraries, adapters, which do this work for you. And well, even though process still very simple process of porting, so it's possible to go ahead with it, and it helped me a lot. And it's very dramatic moment for me because I like to talk about architecture design and okay, guys, I'm gonna talk about design, about architecture design, and I created this picture because it illustrates how our software looks, because when you see code, it's not so obvious how bad it is sometimes. And let's talk about architecture of databases, because it's the weakest point usually. And databases, let's consider that databases aren't some just database core, it's infrastructure around them you're using for databases. And you need to face with caching for database where you need to optimize your database requests. And if you have a big application and you have a lot of joins inside, for example, some kind of relations database, relational database, you can find yourself that you have 18 joins if it's a big application and you need to care about some denormalization, some kind of side databases to store complicated sequences of data. And take care of database itself. I mean, usually normalization is good, but sometimes it makes sense to denormalize some data. It's pretty controversial, but sometimes it really helps. Another issue faced that HTTP layer needs also to be optimized, and you need cache answers for frequent requests. I'll tell about it a little bit later. You need to do complicated operations separately. I mean, I also will explain it, and we'll talk about some API optimizations, and particularly about queries which leverage many of those problems. So, first of all, I'd like to talk about queues. I'm sorry, not queries, queues. So, we have a case, just a case from the real application. We have a chatbot, and backend for this chatbot is written in Koa. It's actually, just imagine that chatbots is a different kind of front end, so we have the same backend behind it. And user asks, okay, so you proposed me to go from city A to city B, and I'm pretty fine with it. And user sends message, okay, please purchase me this ticket, so I'm ready. And sometimes it's not possible to do all the sequence of operations of booking like in the one fit in the one response, because it will take time and our users don't like to wait. So you can provide a response like, okay, we started working, and user will be notified that something is happening, and afterwards we can put all other stuff in queue, provide information that's okay, guy, we purchased your ticket after a while, and send the next message with PDF. So it's pretty good, and splitting complicated operations into simple ones was kind of silver bullet, silver bullet for us, because we hadn't care how to execute a lot of operations in the same time. It was possible to have more time and provide answers like parts of the blocks. What are they useful for? You can use them for APIs, you can use them for input-output operations, you can use them for complex database requests, for sending emails, and all stuff which takes time. I mean, even sending emails, it's okay if you are sending 5, but if you are sending 10,000, it becomes a little bit different stuff. I mentioned caching. It's also quite interesting topic, and situation node isn't that good. You need to write a lot of stuff on your own. So here I just presented several layers of cache and idea of layers of cache. So for example, you have one layer of cache on top. It's API cache. So user come in and say, okay, I want to buy a ticket for plane from Berlin to Amsterdam for tomorrow. And it's kind of frequent request. You know, you can be pretty sure that it was asked like several minutes ago. And you have pretty much accurate price for this flight. You can accurate time. So you can provide answer just from the cache, and you save your server time doing requests to the server, to the database, and processing some business logic. Because usually it's not about just checking something in your database. Usually it involves a lot of third parties, like you check in one third party, afterwards you can check another third party, and it really takes time. And if it hadn't worked, and you passed to the requests, you passed to the database layer, you can find out that different requests from the API can cause the similar queries from the database. So it also might be cached. For example, you are looking for some ticket from another city to Amsterdam, and you can take some information about like change. You can suggest an option to fly through Berlin and suggest part from Berlin or from the cache you have. When I work on presentations, I usually have those to-do labels, and I decided to keep it as it is because it pretty much explains what I want to say. And the point is that situation in Koa.js is terrible here. You won't find anything, and it isn't that good even in Express.js. So just be ready to work on it on your own if you decide to write something big. Another pretty important topic, and it's error handling, and it's what pretty much everyone does sometimes, and it is error handling. And to debug Koa.js applications, I'm using Morgan. I use Forever, which is a pretty cool thing to make sure that even if you forgot to catch some error, your application will stay alive, and it will be resurrected after the error. You can save it to log, and your app will continue working. I used such technology is called no domain, which is kind of deprecated now. It allowed me to use some sandboxes to debug particular places of my code. However, it can be leveraged pretty easily with Zone.js, which I also really like, and guys who worked with Angular probably already know about it. Another important topic is security. In the beginning, I mentioned that having only middleware core is a good approach to have control over the application. And you face the fact that you have no any security from the box, and you take care on it about it. And here are some handpicked libraries I'm using. So I'll just comment shortly all of them. There is Koa CSRF package to prevent CSRF attacks. For passwords encryption, I guess bcrypt is kind of standard. For escaping of data, I use escape HTML. I prefer validate data on the server, even we have validations on front end, and even we sure data is safe. I prefer be sure that we'll save like correct information to database. Even it's safe, but wrong, it can cause problems when we read it. So saving correct information is pretty important. That's validator.js is kind of cool stuff to do. For headers, it's also a very important topic because it's not that effective to take in mind all the headers you need to set and what headers you need to disable. There is some libraries called Helmet. It has some default configuration which will turn some headers on, turn some headers off, and you'll be sure that at least some basic security rules are already in there. And there is a library called Node Security Project. They provide console line interface which checks libraries in repositories and validates are they safe or not. Of course, it's impossible to validate all libraries with it, but as an additional security gate, it's kind of cool. So I guess it's pretty much it from my side. Feel free to contact me, and I'd be glad to answer your any question. Yes.
Okay, so I have a question for you. So for how long did you do this project with Quokka? Koa, sorry.
It's already a third project I'm working on. Now I'm working on my own project written in Koa. And first project went pretty good because it's small. Second one was big, and I went in all those pitfalls, like in a sequence. And it taken for 1 year, about 1 year working on it. And I got some conclusions afterwards. I realized that it was a mistake to use Koa there. And there is some point that I'd like to recommend. I'd recommend avoid using Koa on really big applications. So for some small microservice, it's really cool. However, for something big and complex, it raises question, is it make sense to use Node.js at all for a project? If it's some kind of big enterprise, you'll face many of those errors also on other frameworks.
Okay, so what to do? What framework should we pick to create like a large application? Should we stick to like C# or something like that?
It's pretty controversial, but several weeks ago I've seen pretty cool framework written in Pascal for web. So
okay. Okay, so yeah, thank you. The presentation was pretty depressing because you just told us about all the bad stuff that happened. But if you're saying for the small project, it's
for
okay
small
to
projects,
use.
it's cool, and I tried to demonstrate. It was one of the reasons to avoid being so dramatic. I tried to demonstrate how elegant code becomes if you have a lot of asynchronous stuff happening inside. It's very good. For example, I was working on a chatbot which aggregates gay data from like many different websites. It was providing information about events happening around you, and it checked like literally all the like newspapers which have like event sections on their websites, and for every user request I was checking what is new happening around him. And for big amounts of requests to third parties, it's very cool because it reduces amount of code dramatically. But if you are talking about performance, difference isn't that big. So Koa is slightly faster, but it's not that performance difference you'll notice. You'll notice probably different problems, but not problems you got because you've chosen Express, for example, not Koa. So difference is quite small.
Okay, thank you so much.
Thanks.
Hi everyone. Let me adjust a light at the very beginning. Just, yeah. No, that's too dark. Yeah, that's perfect, I think. So again, hi everyone. My name is Alex, and today I'll be talking about how to build a Chrome extension without any pain. And like you can find the link here. If you click on it, you end up on my website where you can find a link to this presentation and the other presentation I had in the past. So, little information about me. I worked for Opera Software in a browser team. In a desktop browser team. But this presentation is not about Opera. It's not takeaway from Opera work. It's just a takeaway from my experience building Chrome application, because I wanted to understand how it works. And I built some application that I use personally on a daily basis. So the plan today is to, first of all, to be on the same page about what we can build with Chrome extensions, because it's quite old API. I mean, you could create web Chromium extensions years ago, and then we try to see what problems I experienced when I was building my small home project, and try to solve these problems by some tooling. So what is a Chrome extensions? Basically, probably I should name this presentation not Chrome extensions, but Chromium extensions, because obviously Chrome is built on top of open source Chromium engine, and for example, Opera is built on top of Chromium as well as other browsers, for example, Vivaldi and so on. So basically, this API allows you to create extensions for all those browsers built on top of Chromium. Like there are some differences in what you can build for different browsers. For example, like there is a huge Chrome Web Store, probably you know about, and you use it. So there are a lot of applications, extensions, and applications you can install it to Chrome. For example, Opera has a little bit different store. For example, like there are some addition information you can build, addition things you can build with Chromium extensions API, but it is also Opera doesn't support some of the options. So, for example, on our web store, you can install extension which will allow you to install extensions from Chromium shop. So, and it's one of the most popular. So, basically, it's really simple. The only one file is needed to build a totally valid extension, and that file is named manifest.json. In this manifest, you just describe what permissions this extension should have. You describe it like the version, name, and description. For example, when you release a new version of your extension, it will be automatically distributed for all users that install this application. So, like, update of extensions is really easy. You just bump version number, publish it to Opera Store or Chrome Store, whatever, and it's distributed magically. As well, I said you describe permissions. For example, in this small example of manifest.json, we just require to have access to Chrome.browsing.data API to fetch all information about websites you visited a week ago, months ago, year ago. For example, to show some statistics data or to delete this browsing information. Also, you describe some number of optional fields and just say that this extension has a browser action. I'll tell about that, what is it later. Also, you can specify, for example, like it has a background process. It can add some information to context menu when you click on, like with the right button of your mouse. Any page in browser, you can like add new items in this context menu. You specify manifest version and minimum Chrome version, which will be supported by either API or syntax that you use in your extension. Yeah, it's quite easy. So if you create a zip archive with only this manifest JSON without any like a browser action or stuff, it will be totally valid Chromium extensions, and you can actually like upload it, use it in developer mode. Okay, how do you go to that extension menu and how to upload your custom extensions? It's just easy at this. So on Chrome, it's a Chrome extensions. Let's go there. So you can enable developer mode on the right top corner. It will allow you to load unpacked extensions, and you just pick up like just something with manifest JSON in it, and basically that's it. And here you can see that it's like browser action was added at the very top corner of search field. You can enable, disable it, and when you click, you see that bookmarks in my browser because it has permission to read bookmarks. So this small application just creates a browser action. Inside pop-up, you are allowed to search in your bookmarks. Like it's not lowercase, yeah. So something like this, really easy. On Opera, it looks a bit different, and it's not like Chrome extensions, but obviously Opera extensions, like this. But it can also like exit developer mode, enter development mode, and basically it's just the same, it's just different CSS applied on the page. Okay, let's go back to presentation. So as I promised, to explain what browser action is, I'm explaining right now. There are several types of things you can do with Chrome extension. First of all, it's browser action. That is something that adds a small icon on the right side from the search field. Also, there is a page action. It's an action inside search field, and you can enable those actions not for the whole browser, but for some pages that matches some regex. For example, only for google.com. If you enter google.com, your page action will be shown on this search field. So you can kind of limit your extension to work on particular websites. Also, there is a background script. Background script, it's obviously something that you don't see and you can't click on. It's like constantly or not constantly, depends on the settings, like a process, which can has a setup for the whole extension, can connect different parts of extension, help them to communicate with each other, maybe to, I don't know, to receive messages, to write it somewhere, and so on. Also, there is a content script. Content script, it's something that can be run, evaluated in the current window of open website. For example, you can do something like click on the browser action and turn the red color on the page to black color on the page to red, and add floating bubbles or whatever. So that is being invoked in the window object on the same page what you're looking at. And also one of the last but not least, it's developer tools. It's probably you familiar with. It's an extension of default tabs, not only tabs but also tabs here. So you can extend default ones or create totally new tabs like Redux, React, application works, and like basically it's built with the same API I'm talking about. Just depends on complication of the extension. These, how many? 5 things are like cornerstones of any extensions, but there are more options I won't be talking about because you always can find it in API description. For example, in Opera we have several more things to add extensions on the left part of the browser, or to create custom tiles here. It's not a part of the main Chrome, but we kind of extend that. Yeah, so the problem. Basically, that's me when I'm trying to read some websites. I read a lot of news, unfortunately, and some of the websites are crappy. I hate to, like scroll up all the time and get rid of the all advertisement that flows on the left, on the right part of the website. So I decided to solve that problem scientifically and to try to learn something new and to learn new API and to try to few algorithms of parsing the web page. So I built a plugin I called Reader, and basically it's just it's some Russian website about soccer. I read all the time, and there are a lot of advertising different ads here, and actually it's kind of neat because right now we have a really like a low dimension on that monitor, so that's why it looks nice, but when you open it just on a laptop, it's really small, and I can't read it actually. So I built an extension which adds like this icon. It's a page action on the limited number of website, and if I click on it, it just open the same page in reader mode, and depend on time, like daytime, it either turns dark mode or light mode, and it allows me just to read long articles more focused without any distractions. So when I was doing this, first the goal was to try Chrome API because I have to work with some extensions at work, and I wanted to understand better. And the second was just to try to find the main information on the page, get rid of all the advertisement, and to build some algorithms. Yeah, when I was building it, it's just like, it doesn't look fancy. I mean, like, toggle button obviously doesn't look fancy, but for me, it solves my problem. So when I was building it, I faced with some complications, and I want to emphasize these complications and tell you how I solved them. So the complications are, first of all, for example, if you want to build extension only for the latest version of Chrome, it's not a problem, because you know what ECMAScript features are available in the latest version. But let's say that you want to distribute your extensions to all users. And for example, from statistics, from management, I know that we have, like in Opera, we have version number 52 right now released, but some of the users has version 20. It's like 4 years ago, and they don't update, and they demand the quality because they want like all websites to work on the old browser. And let's say you develop some extension that is really nice, and you want to reach as maximum audience as you could. But in this case, it means that you have to use only those language features that are available in that version. Like there are two options. first option is to like to use a can I use website, and let's say I want to use const, right? Okay, let's check which version started to support that. Yeah, actually it's pretty fine with that, but for example, I think await you cannot use it obviously because it just appeared on version, I don't know, let's say 48. Actually, I don't know. So it's really hard, right? And would be cool if you could use a transpiler which solves that problem. You just use the latest version of fancy language, like even in proposal stage, and just leave it to machine to transpile it to the version that you're aimed to. The second problem that it is disaster. After few years working with instant reload and stuff, I just understood that you have to click that small button on that page on every symbol you type. So if you edit a few lines of JavaScript code or CSS code, doesn't matter, you have to go to that page and click reload all the time to see changes in the extension. And it's quite annoying because obviously the extension can have state, and when you reload it, it means that all JavaScript will be invoked one more time, and you don't have state. So it would be nice to have a hot reload, or at least not hot, but at least automatical reload for CSS and stuff. That's a problem number 2. The third problem, it's really hard to communicate between modules. For example, in one extension you have DevTools, background process, page action, and you want to send messages between those modules of the system, but it's quite hard because it's like API is not that simple enough. You have to subscribe a lot of things to a lot of things, and to make up your own like channels, I don't know, protocol or whatever, and it's quite complicated. It's not obvious to get into it, especially if you're not experienced enough. So it's not something like this. You read just an article and just ready to do. And the second is the last is it's really hard to do end-to-end tests. Like let's say for my small extension is not that it's not really important, but I really like testing, automatical testing, and I want to be able to test what I do. So how do I solve that? Did I solve that actually? First of all, I tried to find some Webpack boilerplate to build my extension with that. But like I found even one, but I don't like configuration in my repository. I really like the simplicity of create React app when you just have one dependency and few comments, and you can create like React application without any configuration. So you basically just to type one command and you're ready to go. But I couldn't found one, and it pushed me to write that one. So I made kind of fork of create React app and name it create React Chrome extension. Yeah, it has 0 stars. I hope we can fix it because I just published it several days ago. So what it does actually with npx, it's like command which it's like npm but without installing the command globally. So with that command, just npx create React Chrome extension, then space the name of extension. You can create a folder and installed all dependencies and use several commands that I wrote. First is yarn start. It like runs developer mode for extension, so you can type JavaScript, and it will be automatically reloaded without clicking on reload button. You can yarn build. It just builds everything for production, and yarn generate is kind of scaffolding tool to generate required files and update manifest JSON without like manual work. So it's hard to understand by looking at presentations. So I'll try to show it how it works in real world. So let's name our extension IT Talk demo, and I run it. So it installs some dependencies. So and here we have IT Talk demo folder. So what do you have here? You have src with manifest generated for you, with only one predefined option is browse direction, which does nothing, and HTML also does nothing. So you can start from nothing. That's good. Also, you have several things already installed for you. It's React DOM. Obviously, you can delete it and don't use React at all. Also, it gives me special scripts which hides all the configuration of Webpack and Magic stuff for hot reload, for entry points, and so on. So basically, you just can do yarn start, and it will create a build folder, which one we can load here. IT Talk. So it's on desktop, right? Yeah, it's on desktop. IT Talk demo build. So yeah, we have our super button which does nothing right now. So let's try to, what generate does. Let's try to use it. I'll just interrupt that and try yarn generate. So yarn generate analyze the manifest JSON file that you already have here, and it understands what you can add to manifest. So what we can do is to add page action, to overwrite new tab, history, bookmarks, add developer tools, add background script, add options, content script, or whatever. So let's say I want to add options, and it just generates a new entry point, options.js and options.html, and I can add like hello from options, do yarn start again. Yeah, reload once because we added file. So we have options right now, and here we have hello from options. If I do something here, probably it's gonna work. Let's see. Yeah, it works without any reload. So it's kind of cool. For example, so you can add when you launch yarn generate next time, it do not give you option to create options, because obviously it exists, and it analyzes like dependencies that you have in manifest JSON and allows you to create only one which do not exist. For example, you manually added something here. Let's delete. No, let's just pretend that we didn't create options automatically, and we write that line manually, when I do yarn start, it understands that there are two missing files, and it gives me option to create that. And I said yes, and it automatically creates these files again, and builds application again. So it's kind of really easy start to try Chrome extensions. You can just run a few commands and start hacking. Yeah, let's delete that. So, what's cool about that? Hot reload out of the box generator, which helps with configuration and converts. Yeah, I haven't told you about that. It converts JS using base configuration. So you just specify in a package.json the version of Chrome or Opera you aimed for. Let's say you can write like Chrome 30, and it will automatically convert all JavaScript on the build phase aimed to this platform. So all vars, all consts will be converted to vars. Async await will be converted to special magic hook and stuff like that. So it's really easy to change the version you aim for. What bad parts about this? It's quite new, and it lacks documentation. There is no eject, so we cannot basically eject configuration and to add something manually. But I'm planning to add this. It's quite easy, and there is no test configuration comparing to create React app. But I'm also actually it's kind of cool, but I have something to work on. It's not a disadvantage, it's just incompleteness at that stage, I would say. So the stuff I built, it automatically reloads everything except background script, because when you do change on the background script, it's better just to really reload browse like extension, because it's better just to drop all the states you have in background. And for doing that, there is extension reloader. It's an extension that reloads all extensions except this. And yeah, you can install it, and you have like a button like this. And basically, the difference between this button and this button, there is no difference except that you cannot reach this button on one click before that. But I'm really lazy, and I really like to simplify things, so I added it here as well. So these two things solves first two problems that I had. So let's move further and try to solve problem hard to set up communication between modules. Yeah, I found the project really cool, which uses Redux under the hood. Probably a lot of people familiar with Redux. It's called React Chrome Redux. It's better than my project is in terms of stars. So probably it's more reliable. What it does is just use kind of proxy stores. So for example, you have pop-up script, DevTools, few modules, and in each module you have a store, but actually it's not a store, it's a proxy to the store, actual store, which is in background script. And like in terms of API, it just Redux several instances. But instead of like doing local changes in local store in each module, it automatically proxied to the main store, like the parent one, so like the daddy that is in the background script. Yeah, there will be damage, not at the end. So let me open that one. Yeah, basically, like I created this example with generator as well. So what we have here, background script. We just import wrap store from React Chrome Redux and initialize store as we do in the pure Redux, but we just wrap that store with a function wrap store and specify port name, which will be the same for all modules of your extension. And here we just say that whenever I click on that right button, dispatch add count action. And in my DevTools, DevTools extension, what I do is I just say create new panel, which is called my cool panel. And when it's ready, connect to the store, which is proxied on the port name, and use provider. So like everything down the hierarchy is just basically the same as you would do in a pure React application. So just map dispatch to props, map state to props. So yeah, let's try to build it instead of talking. Yarn build, let's say. Or no, I want to add something. So I want to have hot reload. Okay, so let's go here and load that unpacked extension. It's on the desktop as well. Here. Yep. So it added my cool panel here. And when I click on that extension, here on the right corner, my app in DevTools is subscribed to the proxied store. So I dispatch my action here, but the action is reacted here. I can even close it and open it probably here. Yeah, and it's keeps the state, because the state is not in any visible element, but in the background. And in this particular example, I persist my background, but you can specify so it will be dropped every time you close tab or something like this. And for example, I can dispatch the same action from here, and it adds more things. Let's try to generate a new module. Generate, let's say options, and yarn start again. Yeah, so we have options here, which are empty right now, but I want to add basically the same as in DevTools to render the same app. The only difference is probably like this. I know it has to be defined here. Div ID app. And let's see if it works or not. Something doesn't work. Yeah. Broken link to app. It was like DevTools. Yeah. So I can click it here, open here, and do like this, and it automatically updates the values in all parts of my extension. So it's kind of cool, and the easiest solution of a subscribe problem I found. Really recommend this library. Really easy to start working with it. Highly recommended. So we solved the first three problems, and let's try to approach the latest one. And hard to write end-to-end tests. So and here comes Puppeteer. Puppeteer is a library developed by Google, which appeared not that long time ago. Basically, just kind of a Selenium, I would say. but that not uses any driver above the Chrome, but it uses just internal API, which allows you to rely on the tests with more confidence, because running Selenium tests is always like not that reliable, I would say. Probably a lot of people faced with broken builds because of, I don't know, wait for 3,000 seconds doesn't work because Selenium is lagging. So Puppeteer is like API which allows you to run, unfortunately, only Chrome, but only every browser that is built with Chromium. Let's say that you cannot use it for Firefox or Safari or whatever, but it gives you the way more possibility than Selenium is. And to demonstrate that, I have prepared demos. Some of the demos are really, yeah. So let's start with a simple one. Yeah, Puppeteer. So you can use a Syncowate. It's just Node.js app. You just say Puppeteer launch, open new page, go to opera.com and take a screenshot and close. So when I run it, with Node, example 1, it works first of all, it's headless. It doesn't open the real browser. It uses headless Chromium, and it's really, really fast. It's really fast. It does the job amazingly fast. But for some reason, yeah, wait. Do we have internet? Yeah, it works. So the more complex example, you have a lot of API, almost every API you have in browser. So you can even do a PDF from pages really easily. So let's run example 2. And it creates a PDF from Hacker News page. You can do really crazy stuff. For example, I really like that example. It's a bit more complex, but anyway, it's like 70 lines of code. And what it does, it opens the same page several times and verifies that after the first time, all resources were cached in the service worker. And builds a table of what's saved or not. So Puppeteer is something really, really useful you can play with. You can verify a lot of edge cases, open DevTools, manipulating DevTools with Puppeteer, and does a lot of metric to look for memory leaks and stuff. Let's show you another example. It's called, let me recall, not the text sound, but speech, yeah. Yeah. Actually, it runs a Chrome and uses speech API, which is available only in Canary. Do we have a sound? No? Can we enable it? It's an example. It's called. Let me. Okay. Can I turn on the present like? Okay. I'm really proud of this small part of my presentation, so I don't. Internal speakers. Okay. I hope you will be able. Output. Okay.
Hello, IT Talk. My name is Puppeteer. I'm controlling your browser. Isn't it awesome?
So basically, yeah, it launches Chrome and uses speech API to tell that phrase, and it does really cool things. And maybe the last one is code coverage. Yeah, really cool. So you can like open the page and understand how many of your JavaScript was evaluated on this page, and it does really efficiently. So you can build the whole testing pipeline for your website based on that. But let's go back to our theme, because I'm just lost in these features. You can set up. First of all, open a browser with some arguments, and you can specify for testing extensions that first of all you want to load it headless, to turn off headless option. So basically you will see that the browser was opened, and then disable all exceptions except particular, and point your script to pick up some folder. What I want to do, what I want to test, is this extension. Let me go maybe in downloads. Yeah. So it's motivation. It just asks when you were born. Let's add mine. Motivate. Yeah, and my age. Yeah, I'm spending my time here. So what I want to test right now, that just the plugin was loaded, and to do screenshot. Yeah, let's run example number 3. So I specify the folder where exception should be picked up from, and I run the browser with that exception turned on only, and I go to new tab, which is overridden by that extension, and take a screenshot. Yeah, so it does the work really efficiently. So beside of that, you can like manipulate with all selectors on this page to type the real information to verify several scenarios. But this demo demonstrates the basic approach. So I'm really excited about this tool. Probably I'm gonna create a few more examples and use it on my daily basis in my job as well, because it's really cool. So by this, actually, we solved the last problem, and less pain, more fun. So thank you.
For different, for example, versions of browsers, like Chrome 30.
Yeah, it just uses Babel env. Babel env is a Babel preset, and it just automatically picks up the browser. Let me show.
To any version that you provide?
Yeah, you just provide in the packages on the version, and behind of that it uses can I use database.
Okay.
So the website that is here, but it downloads the whole database of can I use locally Node modules. That's why your Node modules are so big. So, and it understands what features are enabled for these particular versions. So it kind of like opens that your small configuration into the whole, object of configurations available. And it turns on or turns off Babel things based on that. So it automatically picks up configuration, and actually the same with CSS. So the CSS is being processed with PostCSS, and PostCSS takes configuration from browser from can I use as well.
Okay, thanks.
Okay, so I have one more question.
Mm-hmm.
Is there any, because when you publish your extension, is there any validation behind the scenes going on? So, for example, you can create some Bitcoin miner.
I can. But actually, since Opera 51, we have anti-miner protection built in browser. So it's not a problem anymore. Hmm? we just detect like we just detect like anomalies that are happening on the pages and try to block that. But I'm not like the best person to answer that question. We wrote some article on our blog about that, ad blocking and minor protection. On behalf of advertisement.
I want to clarify how you store information about modules dev tool. You talk about external some server, or you save it in your Chromium local storage?
The counter, right?
Yeah.
The counter is being saved in a background process, and it's a permanent while the browser is on. But there are several things you can save actually a lot of information in a Chromium internal database. You have API for that. You have to just add the permission to write to this memory, or you can write to files even. Probably I'm wrong, but so there are several ways where you can store information between sessions. But in this particular example, it's being stored in memory, but in a background process. And background process is persisted when you change tabs. It's just being like, it's just on when the browser is on. But obviously you can dump all information when the browser is being closed, and read it when the browser is being opened, and so preserve state between sessions.
Yeah, it's supposed to be cool.
Okay, thanks.
Just let me try to put it here. Okay, thank you for a nice welcome. Before I start my presentation, I would like to introduce myself. My name is Bartosz Pietrucha. I'm working as a front-end developer, but I consider also myself as a full-stack developer because I've been working quite along with Java, but recently I focus only on front-end. I hold master's degree in computer science, and I've been crafting enterprise software for last 5 years. Before we start, I recently actually found a photo of myself. So this is me in early 2000, maybe 2003, when I got my first computer. And actually since then I started playing with Pascal and Delphi, if you remember those kind of programming languages, like 15 years ago. So I just wanted to show you because this is actually what I found in my stuff just recently. So coming back to our presentation, enough about me. One more thing is that I also train people in Angular. I run Angular Academy. So if you open this website, you would see what we can do for you. We have a bunch of nice trainings. So what are we going to talk about? The presentation is called Scalable Angular Architecture, but the truth is that it's not only about Angular, but in general, we can speak about scalability in the front-end applications, especially single-page applications. So we are going to talk about some high-level principles. Before we jump into that, let's first define what we understand as an architecture, what architecture is. So Martin Fowler says that architecture is highest level breakdown of the system into pieces, or we can also say that he can also say that these are the decisions that are hard to change. In my personal opinion, or my personal definition, is that if you think about a system, so it could be decomposed into different small modules or pieces, and the architecture is means that how actually the system is decomposed into those pieces and how those pieces together communicate, what are the restrictions or rules that govern this communication between those particular pieces of the system, which actually form a bigger chunk that fulfills some purpose, some business need. So how actually front-end applications scale? Because scalability can be understood differently when we think about the front-end or back-end. In the back-end, we understand that we need more servers, we need more capacity, more machines. But in front-end, when we load our application to the client, to the browser, this is a different story. So first of all, what I understand in the context of this presentation, how to scale how the front-end applications scale, grow, it means that our application is actually growing in complexity. We have more and more business rules, and we need to manage it, like large enterprise application. We load more and more data into this application, what can lead to performance degradation. We need to somehow find some means to prevent this performance degradation. Another factor, another dimension of scaling or scalability in the front end could be that our team is growing. We start from five people on board, and then we grow into 100 people on board. We need to somehow manage this factor. People also come and go. People are joining your team in the middle of the project. They also have to get up to speed very fast because we need to deliver business value. And how it usually works. In the very beginning, everything is quite simple. We start a new project. There are not so many lines of code. Everything is understandable. Everybody just code and add new features. But after a few sprints, after some developers rotations, after some refactoring, we start to slow down because things start to get messy. So this graph it's not any scientific research result, it's just my own gut feeling that if you look at this axis and we think of this axis as a speed, we can be either fast or slow, and this is time. So in the beginning, if we don't invest in the architecture, we just develop features, and we are faster than as if we would be, thinking about how to develop abstractions, how to actually create some solid foundations. But then we would be ultimately slowing down, comparing to the situation when we invest in architecture at the very beginning. We build abstractions. We think about how to design it in the long term. So it slows us down in the context of the speed which I understand under the pace under which we provide business value, we build features. But we want to actually maintain the same speed over time. We don't want to actually come to the point that our speed slows down. So again, our goal of what we are going to talk about here is sustainable speed and ease of adding new features, maintainability, because maintainability is a true cost of software, and application performance. So I'm going to give you 5 tips, 5 pieces of advice regarding designing your architecture, your front-end architecture, in three different dimensions. In my opinion, they help to solve 3 different problems: growing complexity, hardship or hardness to reason about the application, and the performance. So we are going to talk about abstraction layers in your front end, about smart and dumb components, about data flow, state management, and lazy loading and proper modularization. But before we jump into that, let's be sure that we are on the same page before we talk about some maybe a little bit hard topics. So how many of you know RxJS? Less than a half. So RxJS is a implementation for so-called reactive extensions. Reactive extensions are implemented in different languages under different libraries, but in general we want to be able to efficiently or maybe easily manipulate data streams. Data stream can be thought of as some stream of changes or events over time. How can we understand this in the context of different data types? Let's think about a single value which is available now. It's just a simple scalar value, just a variable. If we think about array, which is again available now, but provides us with multiple values. And how many of you know promises? Great, all of you. So promise is again a single value which is available sometime in the future as a result of some asynchronous action. And observable is next level because it is the same as promise, but gives us multiple values over time. So we receive one value, then we receive another value and another value. It just doesn't provide us with just a single value, but a stream, a sequence of values asynchronously given to us in some point of time in the future. How can we think about this in a more technical way? How many of you have heard about listener design pattern? So it's very similar, or maybe even the same as listener. We have some observable, something which could be observed upon to, an observer which registers to this observable or subscribes. And then whenever the observable is able to provide us with new value, because for example HTTP request has finished, then it calls next on the observer, and this observer is being given this value. An example of implementation observable in RxJS looks like that. We want to transform an event, a DOM event, like key up in this case, from this element to an observable. The benefit of that is that once we convert this event, native event, to an observable, we have an access to a bunch of cool things. First of one of those things are operators. Those operators allows us to manipulate this data stream in functional reactive way, which means we can use pure functions without any state and manipulate this stream. So what happens here? We are mapping over this stream, so we are extracting some internal property. Then we call the bounce time, which will give us some delay upon which we want to react to this event, because key up can appear in our application whenever a user clicks. So we are not able to like synchronously anticipate it. We need to somehow listen upon it. And then we say, I want to have an event only if this value is different from the other. I'm not interested in the same values emitted from that stream. And after that, I can actually put my handler upon this event so that I can actually implement what I would like to do with this value. Another important foundations before we jump into other topics. Previous presentation, as far as I heard, was concerning Redux. So these are some concepts or terms from Redux, but let's actually remind ourselves with those terms. State can be thought of as values of all variables in given time in our application. And the view is something which projects this state into the user interface. So it's a function mapping this state into some graphical presentation way. Store is a data structure which is immutable, which holds our state. Action is an object that describes which event has appeared, and then there is a reducer which takes this action and is able to transform a current state into the new state and produce new values for that state. Because of its immutable, we need to create a new instance. So these are some principles from Redux. We will be heavily using them in our architecture. And again, how can this be thought in context of web application? Most of the current state-of-the-art frameworks like Angular or React model the front-end application in the tree of components. So if we think about this as a tree of components, this is our container component, this is our table, this is our form, whatever. And all of those components can have some state. The list of loaded users, their state of, for example, I don't know, we have some editor, and then we manipulate some elements. We can have a logged or logged out user, and some of this information should be stored somewhere. So in the Redux way, we are putting this in one single place. Why is it important? Because think about some coordination or sharing some state. Imagine that in different pieces of our application there is the same state. So a simple example will be that if I have my Facebook application and my name is displayed in different places, when I change this name, this change has to be propagated in all of these places when this is displayed. So if I would have different copies of this state in my whole application, I would need to maintain the synchronization of those values. So if I have one store and one place as a single source of truth, I'm alleviating this problem. I just need to change it in one place. Another way of thinking of this is that imagine that my body is an application, my brain is a store, and my hands are components, and I want to clap my hands. I would need to somehow coordinate those hands. So if my state would be in one hand and the state of the second hand would be in second hand, I would need somehow find a sweet spot. Where should I should somehow communicate those states that the position change. If I would have everything in my head as my body actually works, I don't need to I don't need to move the state around the whole body. There is one place when I orchestrate and manage the position of my hands. This is also some analogy that we can think about store. And how the state is manipulated if we have a component and some action happens in this component, then this action is created as an object and dispatched to the reducer. This reducer would understand what this action means and update our store. And again, this state would be projected to the component, and this cycle happens every time we have a change on our web application. So finally, we are here. We are going to start talking about our architecture devices. So imagine that we are building an application, and my idea for providing abstraction layers for huge application that is to scale and last for years is to come up with some reasonable abstractions. So think about your application divided horizontally into 3 different layers. We have presentation layer, which holds our components. It can be Angular components, it can be React components, but I would stick to the Angular because this code and later examples would be based on Angular. But again, these abstractions can be applied to different frameworks or technologies. And then we have abstraction layer. I call it facade. Some people in the community call this layer like sandbox or active record or models. The naming doesn't matter. The purpose of this layer is important. It just decouples what we have in our core layer, the state management, asynchronous services, from our presentation. So our presentation layer does not know if we even use Redux. It does not know how our business logic is handled, because facade abstracts away. You will see later what it means when we see the example of code. So again, this is what I said. Presentation layer is not responsible for business logic. It just displays or presents and delegates to our core layer that some action has to be undertaken because, for example, user clicked or typed something on our UI. So it doesn't know how things has to be done. It just delegates it to business layer or core layer. And it's divided into standalone independent modules. If we have routing like router, it also those modules defines their own routes. And when we think about the state, let's hold for a minute and think about situation when we have some private state. Like there is a navigation component like side nav, which can have different states, like is it expanded or collapsed. This probably is not a good candidate for application-wide state that could be put in the store, because it's rather some UI local private state. We don't want to expose it to the store, to the outer world. We can maintain this feature module, this presentation module could maintain this single small state by its own. An abstraction layer is something which decouples our core layer, which has state management. And if we remember about observables and RxJS, it exposes important for this particular feature module stream of state so that it can be then presented to the user, and API for the given component. So we are not allowing our components to manipulate everything in the store. We are just defining a proper API saying what can happen in this particular module. We'll see later examples of that. And it somehow sandboxes and defines API. So we dispatch actions for this component through this abstraction layer, and we can call those, and this abstraction layer then communicates with the core layer, either dispatching actions or calling some asynchronous services. It is also a good place to implement optimistic updates. Optimistic update can be thought of that we first change our UI, then we make an asynchronous call to the backend, and if it succeeds, we don't need to actually do anything. But if it fails, we need to roll back our UI because we have optimistically updated it. And the last part, core layer, this is the place where we have our core logic, how we actually manipulate our state. This is the place where our reducers live. And this is the place where our HTTP, WebRTC, or whatever other asynchronous services live. And it also, this layer also has the core module, which imports all other modules, defines global services, because we are still in the Angular world, and defines root component. It also has reusable components, configs, utilities, internationalizations. So that's enough when it comes to how we structure our application when it comes to horizontal layers of abstraction. Let's think about data flow in more detailed way. So these colors that you see correspond to the layers. So again, we have core layer, abstraction layer, and presentation layer. And on the bottom, you see some Angular components, because this output and input corresponds to the way we actually pass data in Angular. And whenever something happens, we dispatch an action, our abstraction layer, which exposes this API, allows component to call this function or this method, and then there is an action dispatched to the store. The store then changes its values because there is a new state, and observable passes this new state to the component so that they can present it to the user on the UI. In Angular, components communicate via output and inputs. So this way of communication is imposed by the framework. But on the application level, this data flow should be somehow constrained to this unidirectional flow, because the data flows only in one way. We have to somehow provide this on our own. And this is what Redux does. Redux implementation, which is like dedicated for Angular, is called NGRX. NGRX is a implementation of Redux pattern for Angular. So let's see an example how this data could flow in master detail view example. I have a list of employees, and I have an employee detail component, and I have a container which wraps me everything. So again, we come back to our layers. I have on the bottom presentation layer, there's a container, list component, details component. And I would like to promote an employee with ID 3. So some action has happened, maybe some click, maybe some other action that was coming from the user that intended to promote this employee. Our facade then would call backend service, and if the backend service, which is asynchronous by nature, succeeds, then updates our local state, so dispatches the action to the store. And this state then is going to be reflected in our UI through the observable. And again, the whole cycle can happen over and over, and the data flows only in one direction. So how this could be implemented with our observables in our facade. So imagine that we have a promote method, which then can be exposed to our components, and our components can call them because they have some UI actions, some UI events, and whenever component receives some UI action from the user, then in the particular calls promote method on our facade, so in this case here. And in the pessimistic update, we will first call our API, which is an observable here, and we subscribe to the result of this action. Whenever it succeeds, then we will dispatch an action to the store, which will update our UI. If there is an error, because our backend server, for example, failed, then we don't update our local UI state here. I mean, not local, but we can think about the state which is server state and the client state. And the case here is to somehow synchronize the state. We don't want to have our client have state which diverges from the server state. We want to have proper synchronized state on the client and server. So here we don't update the UI because the server was not able to update its state. That's why we display just the information that we are not able to fulfill your action, and then we don't update our UI state with dispatching action. Optimistic update works a little bit different. First we dispatch an action, and the change is immediately reflected on our UI, and only then we try to update server state. And here, in the case of success, we don't do anything. But in case of error, we need to have an action which rollbacks this change so that our UI would be again in sync with our backend. So this, and what are the benefits? The benefits of this data flow is that we have defined a predictable way that change propagates through whole our application. So if any of you have ever worked with AngularJS and played and have to deal with watchers, he would remember that the data synchronization over different pieces or places in your app is a very hard topic. So if we have a defined way of maintaining the state over the app, it's easier actually to reason about this application. And again, this is very important. If you would be into Angular, you would also have to know that when it comes to change detection, it also has a lot of to do with this, because if we don't follow those principles, we could fall into the problem of, as if it was in AngularJS, calling a lot of functions that has to synchronize different pieces of our application. And third piece of advice is related to what we already have said, so state management. I told you that in Angular, your data flow is defined on a components level is actually constrained constrained in the context of how it's maintained or changed over time. On the application level, you have to come up with your own solution. So this is the logo of NGRX, so the Redux implementation. So again, the state can be only changed via dispatching an action, and every change is propagated to different interested piece of our application, and it's reflected from one source of truth. And every module can have their own slice of state. So we'll later see how can be this implemented when it comes to feature modules. But it's important that even though we have one source of truth with the whole application state, each feature module like admin, dashboard, user, editor, whatever, can introduce their own slice of the state that contributes to the overall application state. Again, NGRX, this is the implementation of Redux that actually fits into Angular very easily because it works with RxJS and exposes us those streams of state so that what I presented here can be easily implemented using this particular implementation. But if we think about a while, this abstractions layer that I presented in the very beginning make our component independent of any state management that we pick up because of this abstraction layer, which we call facade. We just have to be conformed to the API that we defined for the component, and that's it. Over the facade, we can change our implementations and not touch our UI. And how the state can be shared across different modules. Again, if we think about these abstraction layers, this divides our application horizontally, but vertically we would divide our applications into feature modules. And as I said, these feature modules introduce their own state. And let's think for a while how these modules can share their state, because maybe I would like to present something on the UI that comes from the different feature module. So again, I'm not allowing my component to know what is above this abstraction layer. I ask my facade for the piece of the state, and it knows which module, or not which module, but where in the store this state is living. Smart and dumb components, the fourth piece of advice, or maybe principle of highly scalable front-end application. So, have any of you ever heard about smart and dumb components? 1, 2, 3, a couple of you. So great. So, smart and dumb components is a way to distinguish between components which are pure representational, which just present the data, does not have any state, have only input and output, so that the input, you can think about presentational component. If you think about the simple button, which is a native button in HTML, it has an input. The input is a label which has to be displayed, and output, which is the event of clicking, and that's it. It does not do anything more than that. It's pure presentational component. But if we think about the list, or if we think about some container which has which wraps a lot of dump components, we can think about this component as a smart component or a container component, because it reacts to the events that happens that comes from dump components. And important thing is that in our case, it communicates with our facade, so it can communicate with our application. It can actually call some business action. It can make our application call some backend, because the facade or abstraction layer for us provides us with the API to actually do something in our application. So it's usually a top-level routable component, but it doesn't have to be. We can have more container components on one route in our application. An important thing, if we are writing an Angular application for presentational component, we would probably like to use on-push strategy, because in this case, Angular would not observe the changes in this particular component, which would lead to better performance. Because by default, we use a different strategy which observes every possible model change and then updates our UI, so it's consistent. This can be presented in this way. Coming back to our example, we can have item component, list component, and container component. And these guys here communicate to the higher level components that some action has happened, and it has to be somehow taken into account, and the data would be passed down whenever they change for the inputs of these dump components. In Angular, we use different notation for binding this data and binding events up and down. So here, the inputs allows us to bind the data down. So whenever the list of employees changes, this component here communicates this data change down. So again, data flows down, and it's by default in Angular done with this mechanism of data binding. And whenever there is an event, we can also populate this event down via output to the container component. And the last part is modularization. If our application is growing and growing, it's a good idea to somehow modularize it. We have already seen similar diagram. Again, we have our horizontal layers, but vertically we divide our application into feature modules. It can be user management, it can be dashboard, it can be admin module, and every module has everything that is required by this module to fulfill its business purpose. Another part, purely technical, how then, having these modules, can we structure our directories? This is just an example. It works for me. It may not work for you, but I have async folder, which I put all my async services. My dump components usually live in component directory. Container components, smart components, usually live in container folder. Models live in models folder. And then I have a dedicated folder for state when I have reducers, when I have my actions and state. And lastly, I have my facet, routing, and module definition. And lazy loading. Who knows or who knows the concept of lazy loading? Great. So lazy loading is a way to gain a little bit of performance for our application. If we have a very big application with a lot of features, not every feature is needed up front. So we start our application and one module which is like important from the very beginning is needed, it is loaded, and application is working. Those guys are not yet even fetched from the backend. And as the user traverses through the application, we are asking our application to fetch new files from the backend, and then these modules are bootstrapped, and application is able to run those features. And the short code of how easily is to in Angular implement lazy loading. This is our router configuration, and the only thing that we need to do to make our router configuration deal with lazy loading is to use load children. We have to actually get rid of any dependency to the module, and in our router configuration we just pass the URL to the given module, and whenever the user goes to employees, this part would be lazy loaded and fetched on demand from the server or wherever our application is hosted on. And this was the first part. The second part is to actually, in this module, which is lazy loaded, get rid of this prepending part of the path. So these guys here, those paths are going to be relative to our path in our main routing configuration. And it's actually everything. It's very important that it doesn't require any application logic change or any other important changes, because routing or lazy loading in Angular is like opt-in, opt-out. You just go to your configuration, change these two pieces of code, and surprisingly, everything starts to work as expected. So lazy loading is very easy to implement in Angular. Last part, sometimes we would like to use the concept of preloading. So whenever we use lazy loading, and we know that this is the most important entry module we would like to bootstrap, but some pieces, some features are most likely to be used very soon, and we want to preload them. And then we, again, coming with our example in Angular, can do this very easily with preloading strategy. We just implement one single class or one single interface, which is called preloading strategy. And then here we answer the question, if this route is to be preload, then we return load. If not, we return observable of null. And if you are Koa.js, you would see that my configuration has this strategy here registered. So I have a strategy that implements my if-else condition. I register it in my configuration, and having it registered, I can here pass the data that would control my preloading for the given module. And that's it for today. I have shown you 5 pieces. And thank you. 5 pieces of advice. If you want to listen more about Angular, you can visit my website, Angular Academy. Next month, we are going to hold an Angular training, 2 days Angular training. And you can follow me on Twitter. Thank you.
I'm interested if Angular possible in some way from child component store data on state, yeah, state in Redux, because as I see on diagram, it's flow from child component to container.
Okay, let's get. You mean which? Maybe this part?
No, it's maybe further. Yeah.
Later slides?
Later slides. Containers.
Aha, okay.
No. Oh, yeah.
Okay.
And I think about if we can, for example, from employee item save on a store. It's yeah.
You want to dispatch an action here? Yeah, it's technically possible, but again, we want to apply some rules that prevent us from doing that. And in this case, we would like to make this component pure and not play with the store, and just delegate this action to the container, which is responsible for this. In this case, in our container, would have this facet injected, which will communicate with the store and make, because if we have more smart components, application would start to be hard to reason about. If we have most of our components, dump components, on presentational components, it's plain sailing. You just look at this, input and output. It's not nothing to reason about. I understand that this has this input, this output. It's easy to test. It's easy to understand. And if I would be making my every component smart component, if our application would grow, it would be harder to reason about it.
But we talking about a container for only purpose for storing, or it's container for whole application?
Container is the
in
name.
This example.
It's a name. Container is a name. It's you can call it how you want, but this is very. I think this is industry standard maybe or convention to call this smart components container components. It's just a name.
I see. I see. Okay. But it's not main component of the whole application. No. Okay. Okay. Because I thought about it, if it's communication and logic will be in main container, it's grow this container very fast, and
then you introduce another vertical.
Okay. Thanks.
Yeah, I wonder how to solve the problem when a lot of components has to be subscribed to some, I would say, common value. Let me just make a particular example. We have several themes in our application, and when the theme is changed, a lot of our components has to change its visual state based on the theme. And basically, I don't want to propagate the theme value from the very bottom of my hierarchy to the very from the very top to the very bottom. In React, we have a context feature. So if you define a context as the very top, you can get this context as the very bottom without passing it down from the very top to the very bottom. Is there anything like that in Angular?
Yeah, actually, context API is just a simple implementation of dependency injection.
Yeah, kind of, yeah.
You have the dependency injection, so you just inject them store where you want it.
Yeah, so in this case, how it would look like, you just specify dependency that is injected in every component, and you just subscribe, or how it would look like?
You also put and select something from store.
Okay, thanks, community.
This is the power of community.
Dumb component is no longer dumb.
I mean, yeah, this questionable, because if we inject a service which is responsible for this theme, I would think about it, how many times do I have to actually do this? Because again, if I have like a different many levels, and every time I have to pull down the same thing, the color of the theme, I mean, maybe it's questionable. Maybe this is the case when only theme, and it's like agreed on the whole team that only theme is very small, it has only color, can be injected in every place, because if it would be like a very high hierarchy of components and passing it down every time would be pain. And if it's just a theme with no business related logic, maybe you could agree on this small trade-off to inject this theme context to everything so that they can listen to these changes.
Okay, cool, thanks.
I mean, I would need to think about more, but this is like, maybe this is a case, because normally every business-related data would follow this pattern, but in this case it's a theme, so it's a different case.
Yeah, I think there are like different cases, not only theme, but theme is like the most obvious that just came to my mind, but I think that might be different things.
Yeah, by default you try to follow this pattern. You know this pattern,
Yeah.
but there are always such cases.
Yeah. Okay, thanks.
Sure.